Thank you for joining me for this walkthrough through the Chapter 9 practice quiz. So this quiz covers all the ideas that we cover from Lesson 1 up through Lesson 4. So remember, back in Lesson 1, we considered things only with an A value and a C value. Now, the graphs were always called the same thing, okay? The graphs are parabolas. Okay, so that's never going to change. Whenever we're graphing something of degree 2, we're graphing a quadratic, we call the graph itself a parabola. The fact that this 1/2, the fact that that is negative, that is telling us that it's opening down. And since that's fractional, it means it's going to open wider. Then we shift over to that -6, okay? The -6, remember, is shifting the graph down 6, okay? So those were the two things that if A is negative, it opens down. If A is positive, it opens up. If A is a large number, it's going to be stretching it like silly putty, making it narrower. Or if it's a fraction, it's going to be kind of flattening it down and making it wider. And then that C value out back is just moving it up or down. And with that move, it is also going to move the vertex, okay? So remember that shifting will also move your vertex up or down, okay? So after we did that basic graphing, then we moved into more complex graphing. Okay, and by complex graphing, I mean when we have that B term right here. So now we have A, B, and C all part of our quadratic. And when we did that, remember the first thing we found was an axis of symmetry because B is affecting that axis of symmetry. It affects where it's located. And the thing you're going to have to remember is that little formula, okay? You absolutely have to have this formula memorized. So we plug it in. Well, if B is already -8, negative B would be +8. Then 2 times A, if A is 4. So 8/8 means our axis of symmetry is sitting at x equals 1. All right, so first step, there is our axis of symmetry. Okay. Next thing, it says label your vertex. Okay, now remember the vertex lives on that axis of symmetry. So the x value of the vertex is also going to be 1. To find the y value of that vertex, remember, you're going to plug that 1 back in to the original function. All right, so we have 4 minus 8 plus 3. So 4 minus 8 is -4. -4 plus 3 is going to give us a -1. So our vertex is sitting right there. All right. Now, even though it doesn't say to, remember the next step was finding that y-intercept, okay? And the y-intercept, remember, is really, really easy to find because it is literally just taking that 3, okay? That C value becomes your y-intercept in this case. All right, and then it talks about some other point, okay? And remember, the other point that you're looking for should be on the same side of the equation as your y-intercept is. So my axis of symmetry is at 1. My y-intercept is at x is 0. So now I'm curious, for my other point, I'm curious, where's my point at when x is -1? Okay, so I'm going to plug this in. Okay, I'm just going to plug in -1 to see. So -1 squared is 1. So I get 4 times 1 plus 8 plus 3. Well, that's going to be all the way up at 15. So as you can see, that is actually going to be well off my graph. So I can't really plot my other point this time. Okay? But I do at least want you to label that other point, okay? Show me that it was in your head to find it. Then, of course, after you have all that information, now you're going to start mirroring your points across. So here, remember, my y-intercept is 1 away from my axis of symmetry, so I need another point 1 away on the other side. And if I had another point, that point would be mirrored as well. And now I just draw my shape. Okay, draw my parabola. My domain, well, my domain honestly isn't that interesting because remember that's always all real numbers. And the range comes from the y's, okay? Now notice the minimum y is sitting at -1. It's where the vertex is. And all my y's are greater than or equal to that -1. And that finishes up all of the questions that I can ask you about graphing that parabola. Okay? So, now let's keep moving on to where we did, or what we did after our graphing piece. So, after graphing, we moved into word problems. So, a ball is thrown into the air with an initial upward velocity of 40 feet per second. Its height h in feet after t seconds is given by the function h equals -16t squared plus 40t plus 5. So how many seconds will it take until it reaches its maximum height? Well, remember, when I ask you for min or max, that's just a fancy way of me asking you for the vertex. Okay, remember I emphasized that during the notes. So because of that, we need to remember that calculation for the vertex. Remember that calculation? X equals -b over 2a. However, in this case, notice we're not actually using x's, we're using t's. So I'm going to switch that to t, okay, which makes sense because it's asking how many seconds. T is what is tracking my seconds. It's tracking my time. So I get -40 over 2 times -16. So -40 over -32. And I'm going to have to pull out my calculator for that. That is going to give me 1.25 seconds. So that's how many seconds is in the air until it reaches its maximum height. And we want to know, what will the maximum height be? Well, tracking the height is h. So I can use h, so just basically plug it into the function. I can use this to track how high it went. Okay, so again, give me just a moment so I can put this in my calculator. And when you compute all of that out, and I encourage you to be doing the same so you can check to make sure, hey, am I getting the same thing? So when you plug in that calculation, you should get 30. So at 1.25 seconds, the ball is 30 feet high, and that is as high as it's going to go. Okay, that's its maximum. So when we're talking about the range of the throw, remember range is y values, or in this case, instead of y, we're using h. So range is tracking our height. Well, how high is it going? Well, it's starting up at 5. Okay, we released it 5 feet off the ground and is going up to 30 feet. All right, so that is how we're tracking this ball's height. Starting at 5 and then it's going all the way up to 30. So remember, we spent a whole day doing these word type problems. And again, best idea for you, check to make sure you're getting the same calculations as I am so you can convince yourself that you can do this without me. Now, after we did all of that graphing stuff and the word problems, then we started diving into how do we actually solve quadratic equations. We've gone through 2 methods so far of solving quadratic equations. Well, technically 3, but we're not going to test you on the graphing one. We taught you how to solve by finding square roots. So remember, finding square roots, the process was isolate the x squared, then take the square root, and make sure you remember your plus and minus. Okay? Remember, that was kind of the whole gist of what we did that day. Get x squared by itself, then actually square root it, and remember you're getting 2 solutions, a plus and minus. So I'm going to follow that process. I'm going to add the 144 over, then I'm going to square root it. Square root of 144 is 12. Then, of course, I need to remember the plus or minus. For this one, I can add the 64 over. I can divide by 4. That's all part of that whole isolating the square root or isolating the x squared bit. Now square root both sides. Square root of 16 is 4. And then don't forget your plus or minus because ideally you are usually looking for 2 solutions. After we did a day of that, then we transitioned into solving by factoring. Okay? So solving by factoring, well, as the name implies, we need to factor this. M squared comes from m and m, 2 things that multiply to 9 and add to 10 are 1 and 9. And then I need what makes both of those pieces 0. So if I were to plug -1 in there, that would give me 0. Or if I were to plug in -9 to there, that would give me my 0. So remember that step is called the zero product property, okay? Now the important thing for the zero product property is it has to actually equal 0. So if it ever isn't set equal to 0, that should be your first step. And again, it's even in the name, zero product property, okay? So once I have that, now again, the idea here is factoring. Now, this one always gets students, okay? Because it's actually really easy, but it's so easy that you forget it, okay? I have an X in both of my terms, correct? So I'm not going to get 2 parentheses like we're fans of getting these days. I can just pull that X out, can't I? I can factor the X out of both of those terms to get that. And now I can apply the zero product property on this. If I make x equal to 0, that whole thing becomes 0. Or for that, I can make x equal to 5. And then that piece would become 0. And again, that's what I mean by the zero product property. You're checking each individual piece after it's factored to see what would make it 0. Number 9 already said equal to 0, so we're good to go in factoring. And we are going to get n plus 12 and n minus 2 as our two things that multiply to negative 24 while adding to 10. Then, of course, I look, what would make that 0? Well, if I had negative 12, that would make that 0. And 2 would make that 0. All right, so thank you so much for watching this. Again, I'm hoping that you were following along carefully, taking the good notes, and checking all the computations with me to make sure that they made sense and that you can do them as well. So again, thank you for joining me for this, and good luck on your quiz.